Atoms of the chair you're sitting on right now does not need to be simulated with quadrillions of atoms. We just need the outermost layer of it. It might be empty inside, until you decide to break it open. Your body might feel like it's filled with bubbly things, but it might be empty, until you open it. The sun doesn't exist until you look at it. Right now behind you nothing exists until you look at your back. Reality isn't real when you are not observing reality. These creepy things are always happening in quantum world. In real world we just don't feel this because the value of Heisenberg constant is too small. One day I was playing GTA 5 on my low-end PC, low RAM, low graphics card. Game was lagging insanely. Suddenly I noticed sometimes when I drive fast, the road building is not ready yet. All is low in front of my eyes. So how can we say that we are not living inside a simulation? Around us everything is simulation. Universe is loading when we are observing it. Reality is simulation. So, why we don't see our universe while loading when the simulation of reality lagging? Think again, when the game character get freeze, does he realize that the game is lagging? You can say I am touching with my hand around me, I am feeling environment around me, smelling around me, watching the world. Do you? Smelling, feeling, and watching, touching everything is brain signal. These are not real, it is all brain signal. If someone cut your brain apart and put it inside a box, keep it alive by nourishing it from the outside, and if all the signals of sense could be sent perfectly, would you realize that you are really a man of flesh and blood? Do you really exist? Is reality real? Bell's theorem says that if certain predictions of quantum mechanics are correct, then our world is non-local. This non-locals means that there exist interactions between events that are too far apart in space and too close together in time for the events to be connected even by signals moving at the speed of light, breaking Bell's inequality. What does it mean? It means when you are not looking at particle, the particle itself doesn't know at which state it is existing. Read that line again. It is so exciting, amazing and dangerous. Particle itself doesn't know that it is in solid state or in wave form. It doesn't know where it is when you are not looking at it. It's as if the universe around you is slowly creating itself when you are looking around, or just creating the world around you, just as much as needed. Schrödinger's cat. Erwin Schrödinger thought of experiment known as Schrödinger's cat. It is thought experiment in where a cat could be alive or dead when you are not looking at the cat. According to Copenhagen interpretation of quantum mechanics, this thought experiment is possible. It's true. Suppose there is a cat inside a steel box and a radioactive particle. When you are not looking inside that box, the radioactive particle existing in the superposition of two states, decayed or intact. When you look inside the box, the wave function of that radioactive particle got collapsed and it decided to be decayed or intact. If it decayed, cat will be dead for its radioactive radiation. That's mean when you are not looking inside the box, the cat is also existing in the superposition of two states, dead or alive. This is thought experiment proposed by Erwin Schrödinger. According to superdeterminism, our universe is a simulation, some extraterrestrial being controlling our nature from outside. In 1980, John Bell gave an interview to BBC where he talks about superdeterminism. I am putting the interview down. There is way to escape the inference of superluminal speeds and spooky action at a distance, but it involves absolute determinism in the universe, the complete absence of free will. Suppose the world is superdeterministic, with not just inanimate nature running on behind-the-scene clockwork, but with our behavior, including our belief that we are free to choose to do one experiment rather than another, absolutely predetermined, including the decision by the experimenter to carry out one set of measurements rather than another, the difficulty disappears. There is no need for a faster-than-light signal to tell particle A what measurement has been carried out on particle B, because the universe, including particle A, already knows what that measurement, and its outcome, will be. I agree this definition is beautiful and amazing, but it is dangerous too. Austrian physicist Anton Jellinger says that if it is true, then it doesn't make any sense to ask any question. What will we ask? Nature will fix it. What will be the answer? Nature will also fix it. Asking that doesn't make sense, because everything is fixed. To me personally, this doesn't feel good, rather than thinking that I am nothing in this infinite multiverse, not inside a box.